So we have a couple equations here with variables on both sides of the equal sign. In order to get rid of the radicals, nothing has changed. To undo a square root, we need to square both sides. But note that both sides of the equation have square roots, so these equations wind up being pretty nice. Squaring both sides, well, that just gets rid of the radical on both sides. That leaves us with an equation, x equals 2x minus 10. So these eventually become one of those pick on the little guy problems from Algebra 1. Squaring both sides gives you an equation with a variable on both sides. Note the radicals are gone now. And now we just have to go, okay, I've got an x and a 2x. Well, the coefficient here is 1. That's smaller than a 2. So I can subtract an x from both sides. And I can also add a 10 to both sides. X, take away x, those cancel. 2x, take away x. Well, if you have $2 and I take away $1, you only have $1 left. Adding 10 to both sides will mean that x equals 10. Because I had nothing, nothing plus 10 is 10. Still want to double check our work here. Again, we found this value 10. There weren't too many steps. There wasn't too much that could have gone wrong here. But we want to take that 10, substitute it back in, and just make sure that it does work. So if x is 10, then the claim I'm making is the square root of x, which I claimed is 10. I'm claiming that the square root of 10 is going to equal the square root of 2 times 10, that's the 2x, minus 10. So, square root of 10, on the right we have a little bit of work to do. 2 times 10 is 20, but 20 minus 10 is just 10. So this is a true statement. The square root of 10 does equal the square root of 10. We're good. This solution checks out. Jumping over to example 2, there's a little bit more going on, but still not too much. Now I've got the square root of 8 times a. In the first example, the variable on the left was just by itself under a radical. In example 2, there's a little bit more going on. Still the same first step. Squaring both sides removes the radical and leaves us with a nice Algebra 1 equation. Note that now I do have some coefficients on both of these. Pick on the little guy, I have an 8a and a 5a. 5 is smaller than 8, so that's the one I'm going to move. I'm going to subtract 5a from both sides. Notice I don't have to worry about the constant because my variables and constants are going to be on different sides now. So we have 8 watermelons. You take away 5 watermelons, I still have to carry around 3 watermelons. Oh, so heavy. And to get that value a by itself, we can divide by 3. So a is going to be 4. We still want to double check. We're saying that a is 4. I want to make sure that that actually does work. So taking that 4, substituting it back in. Now note I'm going to have a little bit of work to do on both the left and the right to double check this work. So if a is 4, then that means 8 times 4, the square root of that, is going to equal the square root of 5 times 4 plus 12. Okay, 8 times 4, well that's 32. And on the right, 5 times 4 is 20, and 20 plus 12 is 32. Oh, hey look, the square root of 32 equals the square root of 32. No need to go ahead and simplify these. They would simplify the same way either way you do it. So we don't have to break this up into a 16 and a 2. You can if you want the practice, but we know root 32 equals root 32. Those are the same number. So this answer checks out as well. We're going to start taking a look at problems where there's more under the radical than just a variable and a coefficient or a variable by itself. Make sure you're able to follow along with both of these. Eventually we're going to take away one of the radicals from one side of the equation, and then things are really going to step up in difficulty. So go back through, double check that you understand each one of these steps, and also how to check your work. And I'll see you next time.